Before we get into the details of this mysterious and promising planet, take a moment to imagine this. You're staring up at a clear night sky, and somewhere out there, just over 4 light years away, is a planet that might hold the answers to one of humanity's oldest questions. Are we alone? Now imagine we've picked up a signal from that very region. It's faint, focused, intentional. It doesn't match anything we know. It's coming from the direction of a red dwarf star, and the world orbiting it might have water, might have life, might be sending whispers across space. You'd think the world would be paying attention, right? But it came and went, quietly dismissed. Maybe too quietly. That's where this story begins. Proxima b is a planet that's very close to Earth in size. That alone makes scientists take notice. When a planet is about the same size as Earth, it sparks curiosity. Could it also have Earth-like conditions? Maybe, but not so fast. Proxima b doesn't orbit a star like our Sun. Instead, it circles a red dwarf star called Proxima Centauri. This star is smaller, cooler, and emits far less light than our Sun. That matters. The kind of star a planet orbits directly affects its temperature, weather, and its chances of supporting life. And here's where things get interesting. Proxima b sits in what's known as the habitable zone. That's the not too hot, not too cold region around a star where liquid water could exist. And let's be honest, if you're searching for life, water is usually the first ingredient on your checklist. But before you start imagining alien oceans, there are some serious challenges. First, Proxima b is probably tidally locked. That means one side of the planet always faces its star while the other side is stuck in perpetual darkness. Imagine living on a planet where one half is permanently scorched and the other side is frozen solid. It's a harsh world. But that's not the only problem. Proxima Centauri, the red dwarf it orbits, is known for intense solar flares, massive blasts of radiation that could slam into Proxima b. These flares might strip away the atmosphere or make life on the surface extremely dangerous. Still, despite all that, scientists are paying close attention to Proxima b because it remains one of the closest Earth-sized planets we've ever found. And if it holds liquid water, that makes it one of the best candidates for the search for life beyond our solar system. Now, about red dwarf stars. They might not seem impressive at first. They don't shine brightly, they're not huge, and they don't explode with drama like the stars you see in science documentaries. But don't underestimate them. Red dwarfs are the most common type of star in our galaxy. Pick any random spot in space, and chances are there's a red dwarf not too far away. These stars are small, burn their fuel slowly, and can live for trillions of years. That long lifespan means a planet orbiting a red dwarf has a long time to develop life. Because red dwarfs are cooler than our Sun, their habitable zones are much closer in. That's exactly where Proxima b is. Even though the star is dim, Proxima b might still be warm enough to support liquid water, and where there's water, there might be life. Proxima Centauri, however, only emits about 0.05% of the visible light our Sun does. That's almost nothing. But because Proxima b orbits so closely, it still receives around 70% of the infrared energy Earth gets from the Sun. So while you might not be able to sunbathe, the planet could be warm enough to matter. Still, there's a twist. Proxima Centauri is a flare star, meaning it can suddenly brighten up to 100 times its usual brightness, blasting nearby space with radiation. Those unpredictable flares could damage the planet's atmosphere and make it hostile to life. Back in 2020, scientists from the Breakthrough Listen project picked up a strange radio signal coming from the direction of Proxima Centauri. This signal, called BLC-1, caught everyone's attention. It wasn't just random static. It had a narrow bandwidth and a drifting frequency, the kind of qualities you'd expect from a deliberate transmission. Naturally, people started wondering, could this be a message from another civilization? But just as quickly as the buzz started, the excitement was shut down. The experts said it was probably just interference from Earth, and the story faded away. But here's the thing. That explanation doesn't totally add up. The signal came from a very specific point in the sky, right where Proxima Centauri is. Earth-based interference usually appears in many parts of the sky or repeats. But this one? It was focused and never reappeared. That's odd. Also, the signal didn't match any known satellite or Earth-based source. The frequency drift suggested it might be coming from a rotating or orbiting body, like a planet. That part got dismissed a little quickly, while the official word is that BLC-1 was caused by human-made interference. No one has definitively identified what caused it. So we're just supposed to believe this rare, focused one-time signal was a fluke? Even some scientists admitted the whole episode was a wake-up call for SETI, the search for extraterrestrial intelligence. They said it helped refine their search techniques. Fair enough, but dismissing the alien possibility outright feels premature. Now picture this. What if we did confirm life, or even advanced technology, on Proxima b? The headlines would explode. It wouldn't just change science, it would change humanity's place in the cosmos. Suddenly, Earth wouldn't be the only home of life. We'd know life can exist in radically different environments. And if we found signs of alien technology, that could shift our understanding of engineering, energy, and progress. Imagine learning from a civilization that evolved entirely differently from ours. It's a wild idea, but not impossible. One of the most fascinating things about Proxima b is how it's tidally locked. One side always faces its sun and the other is stuck in permanent night. That creates intense temperature extremes. But there's a narrow strip between the hot and cold sides called the twilight zone. This area might be stable enough for water to exist, and where there's water, there could be life. On top of that, strange signals from the dark side have made some scientists wonder, are they natural, or are they something else? Are we hearing distant whispers from another civilization? Proxima b orbits Proxima Centauri, a red dwarf about 4.2 light-years away, around 25 trillion miles. That's incredibly far. Even the fastest spacecraft humans have ever built would take tens of thousands of years to get there. So right now, we can only study it from afar. And that's a challenge. Regular telescopes can't clearly see planets that are close to bright stars. It's like trying to spot a firefly next to a spotlight. That's why new tools are game changers. The James Webb Space Telescope can detect infrared light, allowing us to peek at distant worlds and analyze their atmospheres. Another tool, called Harmony, is being built for the Extremely Large Telescope, ELT, which will open in Chile in 2028. With a mirror nearly 40 meters wide, it will collect massive amounts of light and create incredibly sharp images. Scientists hope the ELT will be able to study light reflected off Proxima b and look for signatures of life, things like oxygen, carbon dioxide, or water vapor. A 2025 study even suggested the ELT might be able to tell the difference between living and lifeless planets in just 10 hours of observation. That's a huge leap forward. But here's the big question. Even if Proxima b is habitable, can we actually get there? Voyager 1, our fastest spacecraft, would take 80,000 years to make the trip. That's longer than recorded human history. So how do we make that journey in a single lifetime? This is where NASA's Deep In project, Directed Energy Propulsion for Interstellar Exploration, comes in. Instead of using rocket fuel, it proposes tiny spacecraft pushed by laser beams from Earth. Imagine space sails catching beams of light instead of wind. These lightweight probes could reach speeds up to 20% of the speed of light, fast enough to reach Proxima b in just 20 years. And then there's Einstein's theory of relativity. According to time dilation, the faster you travel, the slower time moves for you. So on a high-speed spacecraft, time would pass more slowly than it would on Earth. For the crew on board, the trip might feel even shorter than 20 years. This isn't just theory. GPS satellites already use it to stay accurate. And now it might help us reach other stars. Even if we get there, living on Proxima b won't be easy. We'd need to terraform it, essentially remake the planet so humans could survive. One idea is to create an artificial magnetosphere to protect the planet from solar flares. Earth has one naturally, but Proxima b might not. Another step would be altering the atmosphere, maybe with greenhouse gases or artificial clouds to trap and spread heat. The dark side of the planet, stuck in constant cold, could be warmed with technology, heat pipes, engineered ocean currents, or even artificial lights powered by solar panels or orbiting mirrors. If the planet has oceans, they could help by carrying heat around. Salty water freezes at lower temperatures, and moving currents might distribute warmth naturally. I would play a key role in managing and adjusting all of this in real time. automating the construction of our future off-world homes. And then there's the wildest theory of all. Maybe Proxima b already had life. Some scientists believe it's possible the planet once supported living organisms. If that's true, the implications are staggering. It would mean we're not just looking at a planet with a potential for life, we might be looking at a world that's already lived a chapter of it. So we're left with a planet that's close in size to Earth, sitting in a habitable zone, orbiting a common type of star. It may have water, it may have had life, it may have secrets yet to reveal. All we can do now is keep listening, keep exploring, and keep wondering what or who might be waiting out there.